Hello, everyone, and welcome to Google Educators Group Delhi NCR. We're meeting today after a while, and today, of course, I can already see there are so many participants joining us today. So, before we start for the day, just a quick few words, recognizing that we are living in unprecedented times. Situation in India is quite difficult, to say the least. We're being bombarded from everywhere with news. Either we are fighting COVID ourselves, a loved one is, or people we know are fighting this. As educators, I believe it's a privilege for us to be able to, at this point of time, hone our teaching skills as well, using a lot of amazing edtech tools so that we can take back to our students a more enriching and experiential learning, even though we might be located far away from each other. And as we like to say, that the hardest times bring out the best in us. And here's hoping that this too shall pass and we will get to the other side much stronger, much more closely linked with an amazing group of educators from across the world. But before we get started with the day, let's take a little moment to express our solidarity with all those who are fighting COVID, whether they're educators or any other frontline workers, even people who are giving care at home. Let's send out a quiet prayer, a silent prayer to them to strengthen their resolve and to strengthen hopes that we are in this together and we will overcome together. So a quick prayer. Thank you so much. And I think we are all good to go. So let's call in our leader, Sangeeta Gulati ma'am, and our guest for the day.
Thank you, Sanchita. Thank you for giving us the start. And yes, prayers for everyone. And we hope that we come out of this stronger and better. And yes, today's session is going to be a special one. And I'm here to welcome our guest, Dawn, who's joining us from Boston. Dawn, welcome to GEG Delhi NCR. We are very happy and thankful to you to join us today. We have a very excited set of teachers. I think we are breaking a record here with, I can see from my end, 404 teachers who are already joined in on YouTube and otherwise perhaps on our Facebook group. So, you know, the expectations are a lot, but I'm very excited about this because as a maths teacher, when I saw it for the first time, I realized that something that each one of us as a math teacher is missing. The possibility of writing something as I teach and that handwriting turning into a digital maths. Well, that's the magic I saw, and I called it as a magic whiteboard or math board rather than just the math whiteboard. So, welcome, Dawn. And I will not take much of the time, but we would definitely want to hear from you what your background is, what kind of work you've been doing, and how did you come up with this product, which is, I'm sure, going to revolutionize, how we teach maths and how students enjoy maths. So let's hear from you.
Well, Sangeeta and Sanchita, thank you so very much for inviting me. And also thank you for putting the pressure on and setting the bar very high. I hope that I can live up to the expectation. So I'm looking forward to chatting with you today. And for everyone listening and joining in, thank you very much for taking time out of your Saturday evening. And if you happen to be joining from other locations in the world, thanks again for joining. I happen to be based in Boston, Massachusetts, So it's a few hours earlier in the day for us. So you're essentially in the future. If you can give us any predictions for the future, we'd like that now, so we can look into the future. Just joking. That's a time zone joke. Sorry. So again, my name is Don Carney. I happen to be the CEO and one of the co-founders of a company that makes, as Sangeeta was introducing, a math and science teaching and learning tool that's designed to help with instruction and help with learning. And our company is a very research-based organization. The technology stems from some research that was done at a university over here in the research lab. A research university named Brown University. It's here on the East Coast. It's in Rhode Island. So that's where I did my PhD in computer science, and that's where my team of folks in our company, we've all done our research and graduate level work at Brown in the computer science department. So this comes out of the computer science department, specifically in a research lab that was focused on user interface technology and on educational technology. So we've been around for a while. Our company's been around for a little bit more than 10 years, but we have released just recently this Math Whiteboard because, frankly, around the world, and you folks know it now, as I hear in the news, it has been a significant impact on things in India. So our heart and our prayers go out to you, and we hope we get through this pretty quickly. But we've been around for a while, and we noticed during this time of distance learning and this trying time for educators and for learners that there was a piece missing in the way in which we teach mathematics online. As we all know, mathematics is a topic area where the student has to see what we're showing them and teaching them, as well as hear it or be explained the topic. So, for example, I cannot just show you math and have you learn it, and I cannot just explain the math to you. Math is a subject area where you have to both see it and hear it, or have it explained to you at the same time. And whereas there are many whiteboarding tools available that sort of are a shared piece of paper or shared workspace or a whiteboard space, none of them come with mathematics tools built in as first-class objects. So our Math Whiteboard, we believe, is the very first collaborative whiteboard designed very specifically for mathematics teaching and learning. So I'd like to jump in and show you what it's all about. So if we can, I think, Sangeeta, that might be a good time to jump in and show everyone.
Yes. So we will remove ourselves from the screen, and you can share your screen, Don, and I'll get you going from there. Thank you so much.
Okay, great. And I'll also ask if you can remove my camera from the screen, also my webcam, because when I'm working in Math Whiteboard, my face tends to get very close to the screen. That could look a little strange. So,
so you just put your screen up, then I will remove yours.
Yep.
All right.
Here we go. I am sharing my screen now, and here we go.
Yes.
Okay, can you see my screen?
Yeah, just putting it up.
Great.
Yes.
Okay, great. So let me just dismiss this web browser window. Again, here's my PowerPoint slide introducing me, Math Whiteboard, and that's me, Don Carney. And if you need to get in touch with us or you want to try it out, you can go to mathwhiteboard.com. And our Twitter handle is @mathwhiteboard. So let me jump in and show you all what Math Whiteboard is all about. You'll notice that I have two browser windows on the screen at the moment. That's because I will, in a little while, show you how Math Whiteboard can be used as a collaborative workspace between two or more users. But let me jump in and show you what Math Whiteboard itself does. I'm going to expand one of the browser windows, and we will start up a Math Whiteboard. And so before I get started, though, let me tell you a couple of things just as sort of introductory pieces of information that you might be interested in. I happen to be using a Windows tablet, and I'll be writing on the screen a lot with a stylus. Math Whiteboard is a website, mathwhiteboard.com. And it works in a browser, obviously. I happen to be using a Windows machine, but it works just as effectively on any type of device, whether it's a Windows or a Chromebook or an iPad or a MacBook. You can use it across devices because it's running in a browser. I happen to be running in the Chrome browser at the moment. It's also free. So it's free and what we call barrier-free. So it's a free website. You can go to it. And what I mean by barrier-free is that there are no logins or passwords or subscriptions or accounts. It's just a website that you go and you use. So let me jump in and show you what Math Whiteboard is all about. So think of Math Whiteboard as like a smart piece of math paper. For example, I can write some math, 1 plus 2. That's pretty simple math, but you'll see it recognizes what I write, and I can get an answer. 1 plus 2 is 3. I can change the math, and the answer updates dynamically. So 2 plus 2 is 4, or 3 plus 2 is 5. I can change the 3 to an A, and then I can assign a value to A. Right, so when A is equal to 1, A plus 2 is 3. I can change the 1 to 2, and now when A is equal to 2, A plus 2 is 4. I can change this 2 over here to a B, and then I can assign a value to B. So A plus B, when A is equal to 2 and B is equal to 3, is 5. I can write more math on the page, maybe A minus B, or A times B, or A over B. And I can get answers for all of those expressions as well. Now, underneath the hood, we have a very powerful computer algebra system that allows me to do what you've seen so far, simple numeric arithmetic, as well as some simple algebraic arithmetic. But we can also apply this at the higher grade levels where we might be looking at more advanced mathematics topics. And here's an example of a definite integral. And we can solve for things like that as well. So now when I go back and I change the value assigned to A from a 2 to a 6, all of the answers on the page update dynamically. Or if I change B to a 7, again, all of the answers on the page update dynamically. I can even assign to A an expression like x plus 1. And now x plus 1 substitutes for A across the page. So as we know, as math educators, learning math is about seeing connections between things. Here, we're looking at the relationship between A and B with respect to some operators, plus, minus, divide, and so forth. In algebra-oriented topics, we look to see connections between other types of things, like algebraic expressions and graphs and tables. Let me show you an example. So here's a math expression we're all familiar with. It is the slope-intercept form of a line equation, y equals mx plus b. I've written it on the page, it recognized what I wrote, and with a simple gesture, I can create a graph. I'll do that again. With a simple stroke of my pen, just a swoop, like that, we can create a graph. I can now pinch and zoom that with my fingers. If you're a math person out there, you're looking at the graph and saying, oh, we've selected a default value of 1 for m and b because the plotted line here in the graph has a slope of 1 and a y-intercept of 1, but I can change that. I can make m equal to a different value, maybe 2, and the graph updates dynamically. Then I can change this again to a 3 if I want to see the graph update yet again for a slope of 3. I can be more interactive by creating a slider for m, by drawing a straight line down from this equal sign like that. And now I've got this interactive control that allows me to dynamically and interactively change the value assigned to m. Now we can visually see in the graph what slope really represents. What slope? That slope. When slope is positive, it looks like this. When slope is negative, it looks like that. B is the y-intercept. I'm going to create a slider for B. The way you create a slider in Math Whiteboard is when you have an assignment like this, like a variable equals a number, or in this case, B equals 1, we draw a straight line down from the equal sign, just like that. We get a slider for B. And now, again, I can show very visually what B represents. Well, I can change the value of B interactively. I'm not sure we're showing what B really represents here because it's the y-intercept. And shouldn't the graph be moving up and down? Why is it moving left and right? Well, let's take a look at this point. 0, comma B, right? Now, when we plot this point 0, comma B, now we can really see what B, the y-intercept, represents. It's that point where the red line is passing through the y-axis. So there's something I say often, and I think it's really important. Learning math is about seeing connections between things. Here, we're looking at the relationship between an algebraic expression and a graph. You know, often in the math classroom, the math teacher, the math student, the mathematician uses a primary workspace for doing mathematics. That's the paper and pencil workspace that we're all familiar with. Writing on a piece of paper with a pencil. But we always have these secondary workspaces like graphing calculators or a computer where we're looking at maybe a graph or a table or a solution or a diagram or an animation. All of a sudden, we've got these multiple workspaces, and they're all disconnected from each other. They're far from each other. How do you see the connections or the relationships between what you've written on a piece of paper with your pencil and what you see on the screen of a calculator that you've entered with a keyboard? Those workspaces are far from each other, not just physically, but cognitively. So what we're trying to do with Math Whiteboard is bring together into one workspace all of these mathematical representations, allow the user to move very fluidly between them, and then hide behind the scenes all the technical stuff. Let me show you another example that really demonstrates this in a powerful way. This is a related rates problem. So we'll take a look at a couple of cars. So here's one car, and here's another car. And I apologize, I'm not much of an artist, but those are cars. So let's say this is car A, and let's say this is car B, and we will give length to the road, 1,000 units. And then we'll say that car A, we'll write an equation or a function for velocity. We'll say that car A has a constant velocity of 80 miles an hour or 80 kilometers per hour. That's a linear function. It says the location of car A along the x-axis is defined by 80 units of distance per unit time. Car B may be a police car that has to accelerate to catch car A, which is speeding. So in Math Whiteboard, we have this ability to connect hand-drawn sketches with handwritten mathematics. It's called math sketching. Under the More menu, I can turn on math sketching, and I get this little slider that pops up. And on the right-hand side of the slider are these player controls. When I press the play button, we can see the cars moving across the screen in an animated simulation as described by the math I just wrote on the page. Pretty cool. Pretty cool for us, and we're adults. Imagine what happens when you show this to kids in the classroom. Their heads explode. They start asking really great math questions, like, can you make the car go faster? Can you make the car bump up and down? These are math questions that require knowing more math in order to answer the question. But from a very high level pedagogical perspective, really what we're doing here is we're making a connection between this very abstract algebraic notation we see on the left-hand side here and a very concrete example we see on the right-hand side. And that's really important for the learning of mathematics. Being able to, from a conceptual learning or a conceptual understanding perspective, being able to make connections between this abstract stuff we're learning in the classroom and very real world that we live in. How do we apply the mathematics? That's when the learning of mathematics takes place. It's when we recognize or realize that, hey, the math is useful. Students too often in an algebra class will walk in and say, why do I need to learn this? Who cares about algebra? I'll never use this again. But as soon as you realize that algebra can be applied pretty much everywhere, then that's the learning process. That's when you can see how its application is utilized. So that's from a high level pedagogical perspective, but from a very practical perspective, this is a related rates problem. And related rates problems show up on standardized exams all the time, especially in algebra, because algebra is often about rates of change. So here we're looking to answer two questions. At what point in time and what point in distance does something happen? Here the question is, when does car B overtake car A? We can see in the simulation it happens right about there. Well, that's a math observation, not a math answer. We want to get the math answer. How do we do that? There's a couple of different ways to do that. One way to do it is to set the equations equal to each other. We have a system of equations, and usually when we're looking at systems of equations in an algebra class, we'd be looking for intersection points. And we have a very powerful computer algebra system that would allow me to do that. I could set the equations equal to each other and solve for t. Another way to do that I really like to do, another approach to solving this that I really enjoy is exploring. So let's explore the graphs of these functions and then see if we notice anything interesting. So I just plotted these two functions. I drew a big swoop between both of those equations, and I got a graph, and I pinch and zoom the graph, and now we can notice a couple of things about this graph. We can notice that there's a parabola or a quadratic plotted and a linear plotted, and there are intersection points. And of course, that's what we're looking for when we're looking at systems of equations. There's one at the origin, and then there's one out here in the quadrant. The one at the origin, that's where the cars start. The one in the quadrant out there, that's what we're interested in, because that's where the quadratic overtakes the linear. We can see that happens at about 8 units of time and about 650 units of distance. So that's our hypothesis. When, the hypothesis is when time is equal to 8, the car should be at the same location, and that location should be about 650 units of distance along the road. Let's test the hypothesis by running the simulation again. And I'm just going to drag the timer over to 8, and we'll see if the cars are at the same location. Okay, looks like they're at about the same location, but we haven't proven this yet. They could, we're just eyeballing the graph and eyeballing the simulation. Let's prove it. The way we prove things in algebra is through substitution. So I will substitute in the value of our hypothesis when time equals 8 to see if the location of car A along the x-axis is actually 650, what we think from the graph here. Okay. 640, pretty close. If B sub x is also 640, then we have proven the hypothesis. Cool. So I love this example because it shows the power of having multiple representations in one workspace, and everything is connected. You've got this, you've got the algebraic representation, you have a simulation, you have a solution, and you have a graph. We can also look at a table of values, and everything on the page is connected. So when the student said, make the car go faster, well, we can change the 80 miles an hour to 90 miles an hour. And look, all of a sudden, the graph changes. The point of intersection moved. Let's move the graph a little bit. So we moved the point of intersection out to there. The solutions changed as well. And if I ran the simulation again, the accelerating car wouldn't quite catch up. So I'm going to pause for a moment and see if there are any questions or comments, and then I'll continue on. So if you have any Sangeeta,
yeah.
If you had seen
yes,
any
I'm
questions,
here, John.
please let me know. Yes.
Yes, I'm absolutely here. Yeah, people are absolutely amazed at things that you have shown. The only concern or major concern coming in is they are not able to see the tools, the menu bar very clearly. So that could be a concern. So this is for the audience. You can go to the link, mathwhiteboard.com, that I have put in the chat, and create a whiteboard for yourself. Just create a whiteboard. We can just maybe, Don, if you can just show us how do we start, and then they can see these tools a little more closely. If you can just give us open a new whiteboard and show how you have created that.
Oh, yes.
And,
Sure. When you go to Math Whiteboard, just click on when you go to mathwhiteboard.com, there's a little button in the middle of the page that will say, create new whiteboard now. And then this screen will pop up with a blank area underneath. And then if you click the new whiteboard button at the top of the page, that will open up. Well, the first thing it does is it opens up a couple of tutorial slides here. And I always recommend that folks read these tutorial slides. Typically, when you see a pop-up on a web page, you always dismiss it pretty much immediately. That's what I do. But in this case, this pop-up is actually useful. And this will walk you through several of the bits of functionality that are really key in learning and understanding how to use Math Whiteboard from the get-go. So, for example, there's the scribble erase gesture on the middle slide here, or there's a graphing gesture that explains how to create graphs and sliders and so forth. And when you get right down to the page, after the page has been created, there's a menu at the top, and there's a couple of different items in the menu that I have been using so far. And part of the challenge of building a system like this is trying to make the user interface as simple as possible. Although we do some very complex things here with Math Whiteboard, part of the challenge of building this experience is making it a very fluid user experience. So you'll notice that so far I've really only used a few gestures. There's a gesture. I'll write a math expression here: y equals mx plus b. There's a gesture for erasing. That's the scribble erase gesture that I just did. That's for erasing. There's a gesture for creating a graph, a swoop like that. That's the gesture for creating a graph. And then there's a gesture for creating a slider. So maybe we have it. Now I'll put the graph back on the page. And the gesture for creating the slider, when you have an assignment like m equals 1, draw a straight line down from the equal sign, and all of a sudden you've got the slider. So really just 3 gestures. As soon as you master those 3 gestures, you are off to the races. All you really need to know after that is the mathematics. And that's the tough part. Learning our interface should be sort of, the easy part, because there's really just a few gestures. I also recommend for folks who are just learning Math Whiteboard for the very first time, one of the learning curves comes in handwriting recognition of mathematics on a tablet or a touch screen. And that I typically recommend folks to Start simple, write some numbers across the page, 1, 2, 3, and then write some letters, X, Y, maybe A, B, C. And make sure I've trained myself to always look at what was recognized underneath my handwriting. So every time I write something, I always look at what was recognized and then I proceed. And for beginners, folks who have not used Math Whiteboard much, I think they typically don't look at to make sure that what was written is recognized, but that's what I always advise folks to do.
Yes. And of course, there's also a request if you can show us some examples for younger children, for elementary classes, if there is somewhere we can use the Math Whiteboard, and also if there is any possibility of using the Math Whiteboard for geometry. So these are the two requests that have come in.
Great question. I'll answer the second question first. With regard to geometry, we do not do a lot of geometry yet. Stay tuned. We know there are a lot of folks who are very interested in using geometry, well, there's a lot of geometry taught. But in the interest of full disclosure, we don't yet handle too much geometry, but we will in the future. The first question you asked about lower grade levels, that's a good leading question into the next thing I'd like to chat about.
Sure.
So there's one particular feature that I know teachers at the lower grade levels really they really like and they really appreciate about Math Whiteboard. I'm going to show you what it is. So in Math Whiteboard, we have this ability to test for equivalences on a page. So I'm going to, under the More menu, I'm going to turn on Highlight Equivalence. And now you'll see that anything I write on the page, for example, if I write a 3 and I write a 2 on the page, you'll notice that they are color-coded differently. Oh, you know what? I have to turn on a highlight equivalent. Oh, there it is. Okay, good. So you'll notice that 3 and 2 are highlighted different colors. And 4 is not equivalent to 3 or 2. So yet again, it is highlighted a different color. But 6/3 is equivalent to 2. So now it should be highlighted the same color as 2. And we'll give it just a second to catch up here. Come on. Oh, there we go. Good. And 4/2 is equivalent to 2. So therefore, it's color coded the same as 2. Now, you can imagine using this highlighting of equivalent expressions on a page or equivalent numbers on a page in activities you might do at the lower grade levels where we're looking at equivalent fractions and equivalent decimals and so forth. But this can also be applied in step-by-step problems. Now, step-by-step problems happen all across mathematics. And at the lower grade levels, we might be looking at things like order of operations types of problems, where we might be looking at something like this, 2 minus 3 times 2 minus 3. So if we were to solve this, the first step we might take is multiplying the 3 across the parentheses. Let's do that. So this would be 2 minus, and then 3 times 2, that's 6. And then minus 3 times 3, that's got to be 9, right? So that's 2 minus 6 minus 9. But wait a second. It's not color-coded the same as the first expression. I must have done something wrong because we know that every step in a step-by-step problem should be equivalent to any other step. And this step that I've just done here is not color-coded the same as the first expression. So I must have done something wrong. What did I do? Oh, you know what? I forgot to multiply the negative times a negative. That's a plus. So when I scribble out the minus here and I change that to a plus, all of a sudden that expression is color-coded the same as the first statement. So I now know that I've done that first calculation correctly and I can continue on. So what we've done here is really we're giving confidence to the student. We're giving immediate feedback to the student as they're making a mistake or as they're doing things correctly. They know that they're doing it right if they've got the same color, and they know that they've made possibly a mistake if it's a different color. So let's proceed on here. So the next step here, of course, should be 2 minus, and then 6 plus 9, that's 15. Right? 6 plus 9 is 15. So, hey, wait a second. That's color-coded a different color, too. I must have done something wrong. What did I do? Oh, it's minus 6 plus 9. That's plus 3. Oh, okay, so instead of minus 15, that should be plus 3. And I know what 2 plus 3 is. That's okay, so that's color-coded the same. And we know that that's a 5. Right? So, of course, there's always multiple ways to solve any problem. That was one way to solve it. Another way to solve this problem could have been 2 minus 3 times, and then 2 minus 3, that's minus 1 over here. So that is now color-coded the same as the first statement, and I can proceed. So 2 minus, and then 3 times minus 1, that's 2 minus 3, right? Hey, wait a second. Oh, I must have done something wrong again. Oh, it's minus 3 times minus 1, that's right. So that should be, instead of a minus, that should be a plus. And of course, we know what 2 plus 3 is, that's 5. So a pretty cool bit of functionality here that can be applied at the lower grade levels while looking at things like equivalent decimals and equivalent fractions, as well as in a little bit higher when we're looking at the higher levels of mathematics, where we're looking at order of operations things. This can also be applied at the algebra level, where we're looking at things like algebraic identity. So A plus B and B plus A are equivalent, right? So those should be color coded the same. And then we'll take a look at A minus B and B minus A. And those are not equivalent, so they're color coded differently. And then we'll take a look at A times B, B times A, and then A over B and B over A. And those are not equivalent to each other. So we'll see the color coding accordingly. This can also be applied at the higher grade levels, where we might be looking at things like trigonometric identities. So for example, tangent of theta is not equivalent to sine of theta. Right? Well, it's probably not going to recognize mine. That was a weird looking sine or theta. So let me put a better theta in there. So sine of theta and tangent of theta are not equivalent, so they're color coded differently. But sine of theta over cosine of theta is equivalent to tangent of theta. So now it's color coded the same. Pretty cool, I think, that we have this ability to test for equivalences. And again, this can be applied in step-by-step problems, even at the algebra level, where we might be looking at something like this, where we have an expression like this. Maybe we're trying to solve for x here. So the first thing we might do is move the plus 3y over to the other side. And here the first step, of course, would be 2x equals 4. And then we're moving plus 3y over to the other side, right? So that should be 4 plus 3y, right? Hey, wait a second. It's not color-coded the same. I must have made a mistake. What did I do? Oh, you know what? I forgot to change the sign when I moved the plus 3y across the equal sign. Let's change that plus to a minus. And now all of a sudden, it looks like it didn't recognize that correctly. Let me rewrite it. Now all of a sudden, we can see that we've done that first step correctly because it is color-coded the same. And then we can move on to solving the problem. Of course, that's x minus 4 minus 3y over 2. So again, what we're doing here is we're giving immediate feedback to the student as they're stepping through. Oops, it looks like I didn't recognize my y correctly. So we're giving immediate feedback to the student. And like I was saying earlier, it can be very discouraging for students, especially students who are struggling with mathematics, to approach these step-by-step problems, some of which can have 9 or 10 steps, and into which you invest a lot of time as a student. If you're solving 10 or 11 steps in a step-by-step problem, you're taking a lot of your time. And when you get to the bottom and you realize, holy cow, I didn't get the answer right. What did I do wrong? Where did I make my mistake? I spent 10 or 15 minutes trying to solve this thing, and I don't know where I made my mistake. So, either I have to go back and start from scratch, or maybe I'll just give up and move on to the next problem. So again, it can be very helpful not only for the students who are excelling in math to check their work as they're going along, but also for struggling students in giving them confidence as they're solving these step-by-step problems. I think this is a pretty cool bit of functionality. And I think this is a bit of functionality you probably will not see anywhere else. I think this is pretty unique to Math Whiteboard. So I'm going to continue on and show you some more bits of functionality here in Math Whiteboard that I think are very interesting and apropos to our current learning environment, especially with distance learning. Here's probably one of the most important bits of functionality of Math Whiteboard. Math Whiteboard can be shared synchronously between users. So every Math Whiteboard you'll notice has a unique URL. You can see that at the top of the window here in the browser window. When I click on copy link, what that will do is it'll copy the browser, it'll copy this URL into my clipboard, and I can paste that into my learning management system, a course web page. I'm going to just paste that into my browser window on the left-hand side here. And now what we'll see is that the browser window on the left-hand side, which represents a different user on their computer. So for example, maybe the teacher is on the right-hand side and the student is on the left-hand side. So we'll say, maybe the teacher writes something on the screen on the right-hand side, and you can see that showing up in real time, synchronously, on the browser on the left-hand side. And again, these two browsers represent two different users on two different computers, not necessarily in the same room. So that when the teacher writes that on the right-hand side, maybe says to the student, okay, change that to slope-intercept form. So I wrote that originally on the right. I'm going to edit it on the left. So I'm going to change that to be slope-intercept form. So this is the student writing, the slope-intercept form on the left-hand side. Now, of course, this is the Math Whiteboard, and it's a synchronous shared page. So all of the mathematics tools that I've shown you so far are available. So the student maybe graphs that, and then maybe the teacher puts a slider on the page. And I'm going to turn off my highlight equivalents for the moment. So we can put sliders on the page. So what's happening here is that we're sharing this page synchronously in real time, but we've got all the math tools. And anything that changes, one of the users changes. So for example, if I move the slider, that'll show up on the other user's screen as well. So again, this is a tool where we can communicate mathematics at a distance synchronously, and it's really powerful in this environment we find ourselves in with distance learning. Now, what I've learned over the past several months since we've launched Math Whiteboard is that math teachers are very creative people. They've been using a bit of functionality in Math Whiteboard that we did not expect to be used this way. And let me show you what that feature is. So every Math Whiteboard can have multiple pages. You'll see I opened up the slide sorter on the left-hand side here. And I can add a new page by just clicking the plus button. And that'll add a blank page. But what I can also do is I can click on any page, hit Control-C, and then Control-V a couple of times, and now I've got some copies of this. So you can imagine what the math teachers have been doing. They have been assigning to each of these pages a different group of students. So for example, maybe on page 2 we have group 2, and on page 3 we'll have group 3. Okay, and then maybe on page 4 we will have yet another group. We'll call that group 4. That's a good name for that group. Let's say, for example, the student on the left-hand side is in group 3. Maybe this is 2 students. Maybe this is Tara and Mary working together on this slide. So we'll say that on the slide over here, maybe Tara and Mary change their pen color to be green, and they write some math on the page. So Tara is very diligent. So she writes a math expression on the page, and she writes the math expression there on the page. You can see over on the right-hand side that this slide has been updated, because you can see the green there. And then maybe, and that's the teacher, of course, on the right-hand side watching what's happening on each of these slides. And then maybe Mary's kind of goofing off a little bit here, and she's writing, maybe she's writing smiley faces on the page. So the teacher, again, can see in real time as that page is being updated. So a pretty cool bit of functionality that we've seen teachers using in Math Whiteboard to have students working either individually while they're watching them, or having them work in groups while they can be watched. So there's a few more bits of functionality I'd like to share with you, but let me just pause for a moment and see if there are any additional questions that came up.
Yeah, absolutely. Everybody is amazed at the power of this whiteboard. There are quite a few, responses coming in. Of course, it is something that, we'll all have to sit down and try, because you are going super fast for us to keep up. We are losing track of which tool is where. So I think that is where all of us will have to maybe revisit the recording and then open a whiteboard simultaneously, so that you can find these tools. One of the requests that has repeatedly come in is, how did you get this color coding? So this, recognition of the same text that you have shown. Can you just talk about that once more? What settings did you change to get the color coding coming in?
Oh, great question about the color coding. So let me go back. I'm going to just dismiss the page on the left-hand side here. I'll start up a new whiteboard on the right-hand side, and I'm going to expand the page here. Just to give you a couple of pointers in answer to, there were a couple of comments there and one question related to, I'm of course very familiar with Math Whiteboard, and it does a lot, and I'm eager to share all of its bits of, many of its core key bits of functionality with you. So I'm moving pretty quickly. I apologize for that, but of course this will be recorded and I believe available on YouTube, so you can always go back and watch the YouTube video. But just in answer to that question about color coding, under the More menu, we've got highlight equivalents. And when I turn on highlight equivalents, so that's from the More menu on the right-hand side here, there's highlight equivalents. And when you turn on highlight equivalents, anything that's equivalent on the page to anything else on the page will be highlighted the same color, and things that are not equivalent will be highlighted different colors. As you're learning Math Whiteboard, there's a couple bits of, a couple areas here where you can learn about how to use it. There's a help menu up here. When I click on the help menu, I get a little tutorial on how to use Math Whiteboard, and this will walk you through all of the bits of functionality that you'll need to learn. And it's a pretty short tutorial. It'll probably take you a half hour to get through. And as I mentioned earlier, that there was that getting started pop-up, this getting started pop-up. And I understand everyone dismisses this as soon as they start a Math Whiteboard, but you can always get it back. There's a getting started button at the top of the page here. When you click on the getting started pop-up button, you get this pop-up that redisplays on the page, so you can look at some of these bits of functionality that you're exploring. And of course, at the top of the page, there's a link for some example whiteboards, and we have a few example whiteboards there as kind of exemplars for the things that you've seen me do so far. And we'll always be adding more example whiteboards. So you can click on those example whiteboards and open up those whiteboards in Math Whiteboard and then play with them as well.
Yeah, I think thanks so much. I think that has cleared the doubt for everyone, so we can go ahead.
Okay, let me continue. Oh, I'm sorry, go ahead now.
Yes, please go ahead, continue.
Okay, yes. So a couple other bits of functionality I'd like to share with you. Here's a bit of functionality that I think has been very well received, especially with mathematics teachers. Because math teachers are well known to have lots of PDF files, worksheets that they've been saving for years and storing and possibly organizing into neatly organized folders based on topics. I have some worksheets here. I have 9 or 10 of them stored in a folder over here. I'm just going to open one of them. Here's a PDF file, solving systems of equations. And I'm going to open that up in Acrobat Reader. And when I open this, it looks like any other worksheet. It's a PDF file, and it's a couple pages long. So what we can do in Math Whiteboard, or you can do, is you can take any PDF file and drag and drop it right into Math Whiteboard, and then that PDF file becomes the background for your Math Whiteboard, upon which you can do all of your cool Math Whiteboard stuff, like write math. Oops, let me turn my math pen on here. Like you can write math on the page. You can put graphs on the page. You can do compute things as well. I can also, if I like, turn on my draw pen and just annotate the page. What are we doing? We're solving systems of equations by substitution. We're going to solve this problem. There's a bunch of steps here. And then we get down to the bottom, and we solve for x equals something, and y equals something, right? So that's us solving that first problem. Or I can change my draw pen to a different color, and I can annotate this problem over here, and then we can get the x and y down here as well. So what happened here was that we turned a static PDF file that we used to hand out print out and hand out to our kids on paper, now becomes a live, digital, dynamic, interactive mathematics web page that can be shared synchronously with our students. And by the way, you don't have to do all the math stuff. If you don't want to do the math stuff, you don't have to do the math stuff. This could just, in its simplest form, this could just be an annotation tool for PDF files. And in fact, this doesn't have to be a math PDF file. This could be a chemistry or physics or a history worksheet, because it's just a PDF file, and we're just using these drawing tools to annotate on top of it. By the way, this was a multi-page PDF file, so it's got a couple of pages here. Every page in the PDF file is imported as a separate page in Math Whiteboard. So that's a pretty cool bit of functionality, and I think also very pertinent now when we want to utilize these resources that we used to use in the classroom with our kids, these worksheets. We can now share them online very easily. And by the way, you're not printing things on paper anymore. You can just print them out digitally, which makes life a little easier as well. That's a pretty cool bit of functionality. I'm going to continue on here and show you a couple more bits. So I mentioned early on that Math Whiteboard just runs in a browser, and it can be used on any type of device. I happen to be using a device with a touch screen, so I'm writing with my stylus and I'm using my finger a lot to manipulate the graphs and so forth. But if you don't have a touch screen, you can still use Math Whiteboard just as effectively. So far, I've been using the draw pen up here to draw things, like I've been drawing smiley faces, or I'm using the math writing pen up here to write math. So you use the math pen to write math, like 2 + 2, right? And the math is recognized. You would not use the math pen to draw a smiley face because that doesn't really make much sense in math. Of course, the recognizer tried to recognize it as something here, it recognized it as a 0, but that doesn't really make much sense in math. So in the middle, though, there's a math typing mode. When I turn on the math typing mode, now I can use my keyboard to enter math notation on the page. So for example, I'm going to use my physical keyboard. Oh, I'm going to turn off the highlight equivalence for just a moment here. I'm going to use my physical keyboard to type a math expression on the page. So maybe I type y = ax squared plus bx plus c, right? So I've just typed that with my physical keyboard. Now, not everyone knows how to type math with their physical keyboard. How do you type x squared with your physical keyboard? There's a superscript here, and I happen to know the control sequence. It's a Shift 6 or the caret key or the circumflex key gives me a superscript. Not everyone knows how to do that. So we have down below what we call a virtual keyboard. This is like your calculator keyboard, where I can type. I can just click. I can click on that. Oops, I have to move the little StreamYard thing out of the way. I can just click on these buttons down here. So if I wanted to type y = x squared, for example, I can click y = x squared. Right now, I've got my y = x squared on the page. Now, of course, for folks who are just beginning to use Math Whiteboard, sometimes they think that they should use the graphing gesture, that swoop, in order to graph these typewritten math expressions. That's not the case. What you'll want to do is go to the Insert menu, select Graph, and then we can put an empty graph on the page. And that allows us to now drag and drop these math expressions right into the graph area. And we'll see that those graphs are plotted. Now, you'll also notice that A, B, and C are clickable. So I can click on A, and I can click on B, and I can click on C. And I get sliders for A, B, and C. Those allow me, again, to dynamically manipulate the values of A, B, and C. So everything I've done so far with a keyboard and a mouse, can be done just as effectively with, let me restate that. Everything I've done so far with a stylus and my finger can be done just as effectively with a keyboard and a mouse. So now, of course, there's another benefit of using your keyboard on the screen, and that's because you get well-formatted math expressions on the page. Of course, sometimes you don't want to put your big, ugly handwriting on the page because maybe it doesn't look so good, and maybe it takes up a lot of space. So underneath your handwriting is actually a button right there. That's a button. When I click on the button, my handwriting will go away, and I'll be left with just the well-formatted math expression. I'm going to click on that. And now I'm left with just the more well-formatted math expression, which I can drag around the page as well. I can also drag and drop that into the graph area and graph the expression. So now when I change the value of b, we can see both the line and the parabola that have the b parameter in it moving. Now, sticking along the vein of creating a more well-formatted page, we might be doing this because we want to share this with our students. So up here, I have a text box. When I click on the text box entry mechanism over here, I can type math on the page. So maybe I'll type some instructions for my students, like play with the sliders to understand the transformations. Something like that. Those are my instructions for my students. But these text boxes are really cool. I can do some really interesting things. One of those really interesting things is that I can embed a YouTube video in these math boxes, in these text boxes. So I have up here, I have queued up this is a Silicon video playing in YouTube, you know, with every YouTube video, we can always there's a share link, and I can click on the share link. Let me go back to my Math Whiteboard, click on Edit for the second text box on the page here. This will open up a little dialog box here where I can go to Insert, and then I can select Media, and then I can paste an embed code here. I'm going to go back to the Silicon video. I'm going to click on Share, and this will give me the embed code for this particular YouTube video. As well as, I could get other types of code. I could just get the link, but I like to use the embed code here because I want to embed this YouTube video right in my Math Whiteboard. So I click on copy. That copies the embed code to my clipboard. Then I can go back to my Math Whiteboard. I can paste that embed code right into my text box, and then I have got a YouTube video embedded right there within my Math Whiteboard. And of course, this keeps within this stays within the spirit of Math Whiteboard. As I was mentioning very early on, what we like to do with Math Whiteboard is have all of the representations all in one workspace. When the students start switching tabs and switching browsers and switching between devices just to look at different representations, all of a sudden we lose the connections. We lose the ability to see the relationships between those representations because the context is switched. We're in a different browser tab or a different browser window. So again, being able to have everything in the same workspace is really powerful and important. By the way, this YouTube video embedded right there on the page. So when I click on it, it is playing on the page. It's not like when I click on it, it opens up in a different browser tab. You can probably hear the video playing. So let me pause for another moment and see if there are any additional questions.
Yes, absolutely. There are lots of questions coming up, and we've been trying to answer. I have another EdTech enthusiast, Mel, joining in. I think she's been answering. So thank you, Mel. That's a shout out to you for joining us and answering some of the questions in the chat. But one of the clarification that I think we never made to begin with, this product is free. Yes, Don?
Yes, this is free. It's completely free, and it's also what I call barrier free. So there are no accounts, there are no logins, there's no passwords, and no subscription. It's just a free website we can go to and use.
Yes. Secondly, is there any way to save the work? So if you are working on the whiteboard and teachers want to save the work, is there a possibility to do that?
That is a great question. So there are several answers to that question. So I will tell you the couple of answers. Because there are no accounts or logins, it's difficult for us to save things and associate them with an individual because there's no account, there's no login. We don't know who you are. You're just creating these Math Whiteboards. We don't know that they associate with an account at all. But as I mentioned earlier on, each Math Whiteboard has a unique URL, and we don't delete these Math Whiteboards yet. At some point in the future, we may, because we've found a lot of people kicking the tires, and there are a lot of whiteboards that just kind of people create, they play with them, they explore, they do really cool math stuff, and then they don't go back and reuse it. So we may at some point make these Math Whiteboards expire. For the moment, we don't. And the expiration would probably be connected to, if the Math Whiteboard hasn't been used in some period of time, maybe weeks or months, we may just make it expire and go away. But because these are unique URLs, you can, as I mentioned earlier, and I'm going to show you kind of a way to make a copy of this Math Whiteboard. I'm going to, I'm going to copy this page, this Math Whiteboard on the right-hand side here, into a different Math Whiteboard. And what I'm going to do is I'm going to start up a Math Whiteboard on the left-hand side here. And what this will do is it'll create a completely new Math Whiteboard. So we have this completely new Math Whiteboard on the left-hand side here On the right, you'll notice that the URLs are different. So these are two totally different Math Whiteboards. What I can do with the Math Whiteboard on the right is I can copy this page. So I can click on the page, hit Control C, and then go over to my Math Whiteboard on the left, hit Control V, and then I've got a copy of that Math Whiteboard or this page on the left-hand side. So one of the things that teachers have been doing is, you'll say, hey, I want to use this example in period 1 and then in period 2, or maybe I want to use the example again next week in another class that might be a week behind. So I can make a copy of this, and then I can store this URL somewhere. So maybe the copy on the left-hand side is my baseline copy, and the copy on the right-hand side is the copy I'll use dynamically with my students. Because when you create one of these and you allow your students to start accessing it, they can make changes to the page. So that's if you want to stay within Math Whiteboard and make copies of these things, and you kind of want to do it, even though we don't have accounts, you can kind of make copies of these and maintain your URL. And then the third answer to the question is that, as I mentioned early on, our company's been around for a little bit more than 10 years. And we've been selling another product that's called Fluid Math. And Fluid Math includes Math Whiteboard as one of its features. It includes a bunch of other mathematics teaching and learning functionality as well. But one of its bits of functionality is Math Whiteboard. But the Fluid Math system allows, or it layers accounts and subscriptions and logins and so forth on top of Math Whiteboard and its other functionalities. And with Fluid Math, you can actually save these things and then reuse them. So if you really needed to save these and then reuse them, you could get a Fluid Math account and you could save these. And in Fluid Math also, we just added, because that question is asked so frequently, we added a bit of functionality to Fluid Math just recently that enables a Fluid Math user to share to or export to Math Whiteboard. So if you have a Fluid Math account, and you want to create a Math Whiteboard, you just click a button, and all of a sudden, you've got a Math Whiteboard that can be shared synchronously, as well as having your original master copy of the document. Great question, though.
Thank you. So another good query that came up was when you imported the PDF into the whiteboard. Does it become dynamic? Is it possible to, again, the magic of just a gesture and you got the graph coming in? Is that possible with a PDF text that is inserted?
So I think, is the question related to, are we doing OCR on the PDFs? We don't do OCR, so it is imported as an image. In fact, you can drag and drop any image. So these do not have to be PDF files. They could be image files that I'm dragging and dropping. So if you had some image that you wanted to put in here and then write on top of the image or annotate the image, you could do that as well. But no, we don't do the OCR yet on the PDF files.
Okay, so one can just maybe annotate over the PDF, but not use it to draw or to turn it into an active applet kind of a thing, right?
That's correct. So, for example, if I were dragging and dropping this PDF file in here, it's just dragging as an image. And by the way, if I right-click on that image in Math Whiteboard, I can edit the image a little bit. I can change the size. I can make it smaller and bigger if I want to, and then I can position it on the page the way I want it to be positioned.
Right.
Positioned in the middle of that.
Okay, that I think clarifies for Bhavna, who had asked us. Okay, no, Bhavna also had another question here that when she's trying to write the multiplication symbol, which is the cross, it's selecting it as an X. That X had a story with me as well. So what would you use for mathematical operation of multiplication? Is it dot that?
Yeah, that is a great question. We get that question occasion as well. So the X is, when you're writing the X, the multiplication symbol, we recognize that as an X instead of a multiplication symbol. There's a couple of workarounds. So you could do a dot, 7 times 8, for example. Oops, 7 times 8, for example. And that you can see the dot in the middle. And that will give us let me draw the arrow, sorry, over here. That will give us the solution. And the dot could also be a, oops, it didn't recognize my arrow. I just have to rewrite that. The dot can also be replaced with a parentheses. So we could write this as 7 times 8 like that. If you really need that multiplication symbol, and oftentimes at the lower grade levels, you want to have the multiplication symbol because that's what we use at the lower grade levels when we're writing math on the page. Under the math type keyboard, if I just pop up the keyboard here, and let's say I want to do the same thing again, 7 times 8. If I press and hold on the multiply symbol, I get the two different choices. It could be either a dot or an X symbol, and then I type my 8, and then I can click over here. I can click the simplify button, and that will give me the answer as well. So if you really need it, press and hold on the multiply button. That also works for the divide button. So if we want that special divide symbol, I can press and hold and get the various divide symbols to display on the screen.
And do we have the option of using scientific calculator? That's again a question repeatedly coming in. So in this calculator, the keyboard that you have opened up, are there any features specifically for mathematical operations?
We do have a we do have an additional keyboard. So there's at the top of the keyboard on the bottom of the page, you'll see that there are 4 menu items. The first one is sort of the main basic calculator. The second is for more complex operations. So one of the really cool things that folks love is the matrix operations. So you can do all sorts of matrix operations if you want. You can not only can you write with your pen or your stylus those matrices and the matrix operations, you can also just use the keyboard to enter matrices on the page. And of course, down at the bottom, we have some of the more advanced bits of functionality like summations and integration and so forth, limits. So we do have some additional functionality within the math keyboard as well as within the system itself.
Well, there's so much to explore, and one question which I have picked up, I think it will be the last question for today's session, because I know in our curriculum we are very often, drawing system of equations or inequalities. So one of our participants, Minakshi, has asked, drawing 2 equations in the graph is difficult. Can you give us a short demo of, just getting the graph of 2 equations coming together in the graph? And then
Sure.
we'll close at this question, so that the rest, I think, is all about exploring, trying. But I did share the email, the Twitter handle @ Math Whiteboard, so you can always reach out to Don. But let's just have a look at how you can get the graph of 2 equations, coming up simultaneously in one coordinate system.
Sure. Let me show you a quick system of equations example.
Yes.
I'll go back to my math writing mode, and I'll write 2 equations on the page. These are probably not going to be perfect equations here because, but let's do 2x plus 3y equals 4. And of course, whenever I do these examples on the fly, we are not going to get a very clean answer. I want that to be a 4. Let's do 2x plus 3y equals 4. And then we'll do, y equals, we'll do 4x. I don't think this is going to come up too clean, but we'll see. Plus 5. All right, we'll try something like this. And so in order to graph expressions on a page, there's a couple of different ways to do this. You've seen me so far maybe graph one expression like that, and I can graph that and get the graph. I could also graph the second expression like this with another swoop into a different graph area. Or I could graph that into the same graph area we just had. I can do just a swoop into the graph area like that. An alternative way to do this, and maybe faster, is to do the swooping gesture through both math expressions, just like that. And now we've got the graph of both expressions there on the page.
Awesome.
And of course, I can pinch and zoom this, and we can see, yeah, of course, it's not a very, it's not going to be clean. But if I want to get the solution here, I can write x, comma, y with an arrow. And that will give me the intersection points.
Wow.
And of course, I didn't pick a really great example because those are not such clean fractions.
Oh, that was amazing. Absolutely. I think now everybody is getting the hang of it as to, the possibilities that whiteboard opens up for us. No matter what level we are teaching, yes, you will have to explore and see, what kind of features work best for the level that one is perhaps teaching. Yes, isn't that so? It's all about exploring and trying it out. But we have the chat is buzzing. Everybody is really in awe of this. So thank you so much. I'm also going to bring back my team of GG. So oops, sorry, why did I remove? Sorry, I'm sorry, I clicked on the wrong place. So I'm going to remove your screen and bring my team of GEG. So we have Vibha here, who is a maths teacher, and Sanchita, who's a history teacher. So Vibha, what was your take? Because I think you've seen it for
I
the first time.
Right. I'm just super excited right now. I mean, I just cannot control myself right now. It's just too
Officially
much.
mind blown.
Yeah, I know. I mean, graphs like, and also I have a very childish confession to make, Don. I think I explored this tool. I mean, I got to know about this tool about 2 weeks ago. And for the first 5 minutes, I was actually writing and scribbling away. Writing and scribbling away. It was just too much fun. And of course, the graphs coming in, the color coding, it's just too much. I mean,
Yes, and
I'm
in
so
fact, I
excited.
did think of you, Vibha, because you teach a lot of children with special
Exactly.
needs,
Exactly.
because they need to understand the equality of the expression.
Definitely.
So, for them, I think this recognition of equivalence, that is going to play a big role when you are demonstrating the concept and you want them to understand why 4 by 2 and 2 are equal, or whatever simplifications they are doing. I think that's going to be very helpful. So I think
Definitely.
we all can find a lot of nuggets from this and see how it fits into our curriculum. If there's so much more to explore, there was also a demand maybe when you are looking at working on this, how what kind of a statistics we can use. Is there a possibility to get histogram or any other graphs? Because I think as a maths teacher, once you see something, you need more. You want always more. So that doesn't stop. So people want constructions happening on the go and statistical graphs
Yeah,
coming up.
long wish list.
Yes, absolutely for you.
Um, yes, that's great. And again, in the interest of full disclosure, we don't cover all of the mathematics that you might want to cover. We do a lot, and we're always increasing in terms of breadth and depth. So where our goal is to cover more of K to 12 mathematics. So we're hoping to add some functionality at the lower grade levels, as well as expanding deeper into the higher grade levels. As you mentioned, things like some of what you might do in statistics or in calculus or in geometry. We cover them in some ways so far, but we really want to increase the depth in which we cover those things. So for example, at the calculus level, we don't yet do things like area under the curve or volumes of revolution. We hope to do those soon. And in geometry, we talked about that earlier. And in statistics, some of those graphs that we look at in statistics, we don't yet provide those. But stay tuned. Keep asking the questions and giving us suggestions. We really love it.
Yes, yes. I think
Thank
we
you.
are going to bring our wish list to you through Twitter. I think it's at Math Whiteboard on Twitter, right?
Yes,
Yes.
that's
So
correct.
yeah,
Yes.
so all those educators who are on Twitter, just reach out to Dawn via Twitter and ask your questions and make your wish list known.
Yes, please do.
So thank you so much from all the educators. We had a huge number to begin with, and many stayed on throughout the session. So I'm sure it is reaching far and wide all across India, and people will try it out and will give you feedback. And we do hope that we'll come up with some good examples to demonstrate how it has made a difference in our classroom. So thank you so much from everyone here, and we'll stay in touch and we'll see how we can take this forward and maybe give you a demo of how we are using it in our classroom once the life gets a little stable for everyone and the schools start functioning again here in Delhi as well as all over India. Thank you so much. And a prayer to everyone, stay safe, stay well. Yes, Don, any last words to wrap up the session?
And thank you so very much for inviting me. And as you just suggested, please share with us and with anyone your use of Math Whiteboard. We love to see examples of it. We love to see how people are using it, and we love suggestions about how we can make it better. And if you can share this with colleagues and friends, maybe folks who were not able to attend today, that would be awesome as well. And again, our prayers and our heart goes out to you in this very trying time we know you're experiencing in India. So be safe and be healthy, and we hope we get through this smoothly and safely.
Thank you. Thank you. And bye, everyone. With this, let's wrap up today's session. Thank you for joining us today, and hope to bring more interesting sessions in the coming weeks. So stay tuned. Bye, everyone.
Bye.